Good morning,
Good
ma'am.
morning.
Hello, good morning, everyone.
Morning.
Respected authors and invited guests, welcome to the technical session 10E. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you all to the 10th International Conference on Smart Trends in Computing and Communication, SMARTCOM 2026, Pune, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Pune, India, and the virtual event is being held through Zoom from 2019 to 21st January 2026. I hope you all will enjoy the knowledgeable and interactive sessions. And in this session, we'll be having 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for the question and answers. Upon 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you stay with me till the end of the session. If you have any kind of query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to today's session chair, who is Dr. Meenakshi Raut. She's an associate professor in the School of Computer Engineering at KIIT University with over 20 years of experience in teaching and research. Her areas of expertise include data science, machine learning, and generative AI, with active contributions to academic excellence, research, and student mentoring. Ma'am, would you like to address the participants?
Yeah, very good morning to all of you. All the best to the participants, and we can start the session. Thank you.
Yes, thank you so much, ma'am. Now, I'd like to call upon our first presenter of the day, Shweta Shri P. Ma'am, to present her paper titled How Does Gamified Learning Analytics Influence Student Retention in Higher Education Institutions? Over to you, ma'am.
Good morning, ma'am. Can you hear me?
Yes, you're audible, ma'am.
Yes, ma, audible, ma, please.
Yes, ma'am. I'll be sharing my screen. Yes, ma'am. Is my screen visible right now?
Yes, ma, visible.
Yes, it's visible. You can start presenting.
Good morning to everyone and good morning to the panel members. So I'm Shweta Shri and I'm from SSN. So our topic is about how does gamified learning analytics influence student retention in higher education institutions. So basically here we will be seeing about the background and motivation research objectives and key factors of how we have determined and about the grayscale influence method which is known as the GINA method and how data collection and analysis have done and the result most of the influential factors, and we will conclude with implications and conclusion. To begin the presentation, moving on with the background, many students have been retentionally and seriously falling down and dropping their higher education rates. This is a serious dropout which we have to look for. So, and learning analytics have been made to note how many real-time progress tracking of early detection and how risk learners have been dropping out their education. We have identified the gap between the work and the research that prior studies often focus on engagement and motivation, but does not rank casually influence among the retention factors. So the research gap would be that identifying the casual influential relation between how gamified learning analytics and factors improved and how it can be hierarchically made as a framework to help the educators prioritize interventions. And here are the 7 factors that we have used as a key to analyze this. Sustained learning engagement, which we take as SLE, where we have been consistently participating in tasks, discussions, and supported by game elements and tracking. It is based on tracking and the game elements and the noting down how the consistent participation have been. And second factor has been data driven early risk detection. It is completely based on analytical and data driven modules so that we can learn about how low grades and low logins and missed deadlines can influence the people of dropping out the higher education studies. And third will be the motivation reinforcement system, which is a mechanism for the mastery, and it will be the point and rewards based on the reinforcement of the sustaining effort. And fourth will be the personalized learning intervention, which is PLI, which is a data informed tailoring of resources, challenges, and milestone, and mentoring to the individual needs. So fifth factor that will be considered as an analysis is that social beginning and peer support. So it is all about talking about how our peers, strengths, and team leaders have been strengthening and engaging ourselves into this society and how they influence us into persistence of higher studies. And sixth factor will be the transport progress visualization, which will be there is denoted in the visualization bar about the clear process of how indicators improve the accountability and the goal commitments. And our seventh factor will be adaptive challenge structuring. We will be looking off the optimized challenge zone, which we will be taking the difficulty and adjusting task based on the rates. So these are the seven factors that we will be layering off, and we have analyzed to showcase this game of learning analytics factor. And the methodology we have used is gray influence analysis, which is GINA method. We collected data from the expert judgmental on casual influences, and we have converted it to a Likert scale from the ratings. And then we have converted the data ratings into a grayscale value and computed the direct value and the total influential metrics. So drive influence and responsibility has also been taken into an account, and rank factors have been based on the hierarchical prioritizing of the framework. And based off these seven factors that we have taken earlier, we are converting those factors into a grayscale factors and finding the aggregate values. And these aggregate values are noted in a table, and then the values are being whitenized to another value, finding the critical, ideal, and typical values, following with the grayscale conversion and aggregate value, and then moving on with the complete influential coefficient. Whereas we have been taking the direct influence coefficient and also an indirect species, and we have been talking about the responsibilities which will be directly converted into a responsibility. So these seven factors are finally being converted into an gray importance and then as the most influential factors. And the most influential factor when analyzing these seven factors is find out to be sustained learning engagement SLE and personalized learning intervention. These two factors are majorly impacting students for pursuing into higher education studies. So the data and system design, study design will be the participants. Primary data can be taken from the census of gamified learning analytics. And we have 23 academicians with teaching and research experience in this kind of context. And we have been structurally queries-based interviews. We have collected data and we have been analyzing through that. An instrument is that, as I have told earlier, we are using the Likert scale, which is a rating between very low to very high. And the mapping have been done based on the ratings, and it has been converted into a grayscale and whitenized for calculation. So the output will be GIC and GRE, which is gray for influential rate, and it will also be in gray relational coefficient. These two matrices and the total influential scores will be analyzed, and the risk ranked the list of the factors in the hierarchical model from most, moderate, and the least. So result inputs, this will be the results of what the influential factors. These are the seven factors here we have collected, and also the critical, ideal, and typical, and aggregate and total influential values have been taken. So the reading guidelines is total influence will be the grayscale index and also the grayscale relation coefficient. So calculating and accommodating these two values will get the total influence of how the dropping out of higher education and highest values have done, and stronger overall impact will be the retention system based on these kind of two values. And as I told earlier, the SLE and PLI will be the most top two influential factor with a rate of 0.29 and 2782, and PLI will be standing the second with 0.28. And DD, will be standing with behind with the 0.2. And these are the top three factors that are really affecting the higher education students. Using this like 80:20 view, we can say that these SLE and PLE are the most strongest drivers which we bring off with the influencing factor of higher education studies through gamified learning. And interpretation, why these two are leading. So sustainable learning engagement, in the sense it is a consistent participation creational beyond the behavior and performancial signals needed for analytics. So in practice, we say that micro wins and frequency submissions, discussions and participation, weekly KPIs, and all which consider SLE. And personalized learning intervention, in the sense it is a difficulty and mentor support system that reduces the frustration and keeps learners to progress. In practice, we also say that the just-in-time material and tutoring triggers, which will be motivating the students, motivating the educators to further pursue for the higher education. How it connects to other factors is that as these two factors are strongly early detection factors, this can be indirectly or directly affect the other factors by giving a better progressive visualization and adaptive challenges. So that in SLE, it is in sustained learning. So it whereas it has been including the peer supports and belonging also, so that people can be other factors can also influence the leaderboard and team, so that people can easily keep these two as the main factors and other factors as a sub factor, those can influence that. The hierarchical model and the level is that sustainable learning has been top and personalized learning, followed by data-driven risk detection and transparent progress visualization. These all comes under moderate influencing factors, and the least influencing factors will be motivation reinforcement system. So most influential is SLE and PLI, and least will be adaptive challenge structuring and motivation reinforcement learning. So the basic takeaways will be building a sustained engagement first and then personalizing the intervention, layering of the analytics for early detection and then process reliability. Implementation play a role for the educators. So sustained educators, people can be having a clear KPIs. KPI in the sense in which include weekly activity, submission, discussion rate, and which can be engaging to the student and the mentor, so that people can engage with them very genuinely and can also sort out the things. Personalized support in the sense, just in case about tutor, we can have a personalized one-to-one interaction between the tutor and the mentor and the students. Detect risk early. It should be that alert for low logins. There will be an alert sent for low number of logins if the attendance percentage is low and the student is not willing to come to the education institute and missing off the deadlines and falling in. These can be, instead of discouraging or disengagement, it can also lead to a dropout, so that it can be encouraged and it can be changed off into some other factors and the number of risk can be increased. Reinforce movement. Dashboards and progressive bars can be made, which with the not as a comparing to their peer teammates, but as an competitive, as a healthy competition between adaptive students and the peer mates, so that it can bring an healthy adaptive environment for the students to pursue for the higher education. So for the educators.
Respected presenter, you have 1 more minute left.
Yes, ma'am. And the finally, we are talking about the implication. In the implication for education and policy makers will be that there can be a personalized learning interventions, adapt in milestone targeted hints, and tutor and mentor can have a supportive learning struggles and using of visualization dashboards and alerts and behavioral signals. These can be improved and peer supports can be improved, and visibility of to a sustained movements over the semester can also be improved to encourage the students to go into a higher studies or educations. And the limitation and future work would be we have been futurely incorporating students' perception and AI-based predictive analytics for early interventions. This will be the future scope of this work. And the conclusion will be that SLE and PLI are the strongest driven factors of the retention, and analytics should be used to detect earlier risk and process transparent. So these are the reference paper that we have come across to propose this work. And yes, ma'am. That's all about the presentation.
Okay, Swati. See, this it is not for the Swati, it is for all the participants who are going to be present today in this session. You should not read out the materials you have over there in the presentation. You have to make us understood what work you have done. Okay. So I feel that you have totally read out all the story, which I didn't grasp anything. But still, I have one, two little questions. If you're able to answer, just tell me. You just tell me how this gamified learning will be different from the traditional learning analytics. Unmute yourself.
Yes, madam. We are the supervisors of her. Here, she is a currently second year UG student. So
Okay.
the gamified.
Okay.
So this is the we are using for the here. It is a gamified learning towards to this for this. So virtual environment and all other VA. So all this everything we are towards this. Maybe this is advanced versions are remaining. It is there in future work.
It is
So
the initial stage, no, sir?
initial
Is it
stage.
in?
Yes,
Yes, yeah. Okay. Okay. So I just want to know, okay, the inputs that you have given the inputs to this model, the input has been collected.
yeah, yes, madam. Primary data collection. So we conducted the primary data
Okay.
survey.
What age
So
group has been focused, sir?
so actually we are not focusing on age group, madam. Minimum 3 years to 22 years experience our respondents was there, madam. So the
Is
in the
the
teaching field in higher education, madam.
higher educations.
Higher
Okay.
education.
Okay. So
So
what impact you
included
find?
gender diversity also there, madam, mixed with male, female, yes, madam.
Okay, okay. Not is. Okay. If
And
it is a
different
preliminary stage,
geographical locations also we covered, madam. Yes,
in this study or in the future
in
we are
this
going
study,
to?
madam, in this study, madam, with the respondents are in the different geographical location, and both the genders are involved in this study, madam.
Okay, sir. Thank you.
Thank you, madam. Thank you.
Yeah.
Thank you for your presentation. I would like to call upon our next presenter for the day, Vishal Bharat R, to present his paper titled A Comparative Analysis of Machine and Deep Learning Methods for Detecting Offensive Language in Tweets. Over to you.
Yes, ma'am. Is my screen visible?
Not yet. Just share your screen.
Is it visible now?
Yeah, it's visible now. You can start presenting.
Yes, ma'am. My topic is comparative analysis of machine learning and deep learning models for detecting offensive language in tweets. The main problem statement is that social media platforms like Twitter generate a massive volume of user content along with the useful communication and rapid increase in offensive and abusive hateful language. The
Make
manual
your
moderation
video
is not
on.
scalable.
Hello. Excuse me.
Hello.
Make your
Hello.
video on while you are presenting.
Yes, ma'am. Ma'am, is it okay now, ma'am?
Yes, go ahead, please.
Yes, ma'am. Manual moderation is not scalable and automated detection requires. So the tweets are short and informal, noisy, often sarcastic, making detection difficult, ma'am. So the objective of this project is to compare traditional machine learning models and deep learning models for offensive detection classification in tweets. The main goal of the project is to evaluate the machine learning and deep learning models for offensive language detection. To analyze this, we have used an accuracy matrix of accuracy, precision, recall, and inference score. They have used two data sets. One is a binary classification data set, another one is a multi-class data set. In binary classification data set, it has two labels. One is offensive and another one is non-offensive. In multi-class data set, we have used three labels. One is hate speech, one is offensive language, and another one is neither or not. The proposed idea is first that when we have the Twitter data set and we have to pre-process the data set, and from the pre-processing data set, we have to extract the features and we have to train the features with the machine learning and deep learning models, and we have to evaluate the metrics and we have to set the models. The techniques, the pre-processing techniques include uh, the text pre-processing to ensure effective offensive language detection from Twitter data. Tweets are inherently noisy and informal containing URLs mentioning hashtags which makes the Twitter makes very difficult as they are very normal over here. If therefore pre-processing begins with lowercasing to ensure uniformity and reduce volume. Uh, and next the contract expansion as there are short forms of the many words. Example, can be written as cannot. Like that, many of them are there, and URLs and user mentions and hashtags are removed so that they do not contribute meaningful semantic sentences over there. And punctuation and special characters are eliminated to prevent token fragmentation and reduce noise in textual representation. And stop words is removed to apply to discard frequently occurring words that carry minimal discriminative value. Then the text is tokenized using tokenizations, and to further normalize the text, lemmatization is performed to perform converted words to their base form. In the feature extraction techniques are employed to convert clean textual data into numerical representation for suitable and of suitable model training. To represent tweets by weighted words based on their importance within the tweet and across the entire corpus, therefore highlighting discriminative offensive terms while down-weighted common ones. Additionally, word embedding techniques like word to vec and glove are utilized to capture semantic relationship between the words represented them as a dense vector and the continuous space. For deep learning models, particularly transformer-based architecture like BERT, contextual embeddings from BERT are unemployed. Unlike static embeddings like embeddings, BERT generates word representations that better understand suitable offensive cues and sarcasm and implicit pinnings. Together, these pre-processing techniques and feature extraction techniques ensure meaningful and clean context-rich input representation, forming a strong foundation for accurately comparing machine learning models and deep learning models in offensive language detection. We have used eight machine learning models, which is logistic regression, support vector machine, naive Bayes, random forest, and gradient boosting, KNN, and QDA. For the result of the machine learning models, in which gradient boosting outperformed among the machine learning models with an accuracy of 0.90%. In the deep learning, coming to the deep learning side, we have used five deep learning models. One is LSTM, BiLSTM with attention, CNN, and hybrid LSTM and CNN combination, and a BERT model. And coming to the result of deep learning models, BERT model performs the best among the deep learning models with an accuracy of 0.92 percentage. The conclusion is the deep learning models consistently outperform traditional machine learning models, as with the transform-based models, BERT showing best performance. Naive offers good balance between efficiency and predictive accuracy, while gradient boosting achieves the best results among the traditional machine learning models. Selecting the model requires balancing computational resources, as CNN or Naive are better for limited resources. BERT is good for accuracy, but deep model risk overfitting and have high resource demands. For future work, should focus on specialized pre-training, regularization, and efficient hybrid models. Thank you.
Yeah, thank you. So you have taken so many machine learning and traditional learning algorithm, deep learning algorithm, sorry.
Yes, ma'am.
Just still tell me why you have thought of to compare machine learning with deep learning.
Ma'am, to provide a systematic and practical grounded comparative framework in the machine offensive language detection, ma'am.
No, systematic learning means you have applied machine learning for classification. You have applied deep learning for classification. So it is the final stage where you apply your input to get the classification output, that whether it is offensive or not offensive, isn't it?
Yes, ma'am.
And we know that deep learning is designed to perform better than the machine learning. So why the thought come to compare machine learning and deep learning? Because deep learning is there to perform better than the
Ma'am,
machine learning, isn't it?
yes, ma'am. Yes, ma'am.
If I'll tell you
Ma'am,
ki we will make
but
a comparison between you and your professor. So obviously your professor is better than you. So what is the point of comparison of ML with deep learning?
ma'am, in real world situation, the deep learning system is very much complex in deployment, ma'am, as compared to machine learning models. As the computation cost of deep learning models is very high, the main idea of this project is not proposing a new idea, but to provide a practical and grounded comparison between the machine learning and the deep learning models, ma'am.
Okay, thank you.
Thank you.
Thank you for your presentation. Now I'd like to call upon our next presenter, P. Aruna ma'am, to present her paper titled A Comparative Study of Image Upscaling Techniques by Cubic Interpolation, EDSR, and Waifu 2X. Ma'am, are you present? Okay, if she's not present, we can move on to the next presenter. Sanson Sando S. Sir, to present his paper titled A Multi-Objective Cubo Framework for Real-Time Sustainable Vehicle Routing. Over to you. Are you present, sir?
Hello, good morning, ma'am. Ma'am, am I audible, ma'am?
Yes, you're audible.
Yes, ma'am. This is Adina, ma'am.
Uh,
Shall we start presenting, ma'am?
yes, you can start presenting.
Thank you, ma'am. We'll share the screen now, ma'am. Is it visible to you, ma'am? Ma'am?
Yes, it's visible.
But what
It's
is the
visible.
paper ID?
That is right.
What is the paper ID?
The title is Comparative Study of Image Upscaling Techniques Using Bicubic Interpolation ADS.
Excuse me, I'm asking about the paper ID.
Yes, ma'am. My paper ID is 924, ma'am.
924. Okay, please go ahead.
Yes, ma'am. Yes, ma'am. So this is the agenda. Madam, this is the agenda of the paper. So starting with the abstract, image upscaling enhances resolution and visual quality for digital media and medical image. Bicubic interpolation is fast and efficient, but often produces blurred details. EDSR provides superior texture and edge resolution with high PSNR and SSIM at higher computational cost. So the evaluation uses PSNR, SSIM, processing time, and subject to visual quality. Results show a trade-off between quality and complexity, with ADSR performing best for high resolution tasks. So the introduction is image upscaling improves resolution by maintaining visual quality, widely used in medical imaging, surveillance gaming, and digital media. Application methods for blurring lots of details. Cubic, it is fast but smooth fine textures. EDSR, it's high quality deep learning approach with high computation cost. And Wave 2x efficient for styled images with noise reduction. This work compares these methods to identify the most suitable upscaling techniques for different applications. This was the Vaping study. Image upscaling has evolved from interpolation to deep learning methods. Bicubic interpolation provides smooth results but causes blurring of VDSR achieves high quality super resolution using deep visual learning. High accuracy of VDSR comes with increased computation cost, and it is suitable for bandwidth efficient digital platforms and image restoration. The problem statement here is conventional image upscaling methods provide fast results but suffer from blurring and loss of fine details. Deep learning based techniques achieve high quality super resolution but demand significant computational resources.
Excuse me, dear presenter, your voice isn't audible. Can you speak a bit louder?
Okay, madam. Can you hear me now?
Yes.
Madam, can you hear me now?
Yes, yes, you're audible now.
Different image data types require different upscaling strategies with no universal solution available. Lack of systematic comparison to guide method selection based on quality and efficiency. Need to evaluate upscaling techniques using objective and subjective performance metrics. These were the problem statements. So these are the research objectives. To present a comparative evaluation of classical deep learning based image upscaling techniques, to analyze the performance of biometrics based on an SSI, to examine the trade-off between quality and computational complexity, to assess the applicability of each method across different image categories, to provide insights for selecting efficient upscaling techniques for real-world applications. The methodology used is we selected three upscaling approaches: bicubic interpolation, EDSR, and Wave 2x for comparison. Used 2K high resolution dataset to train and evaluate deep learning models. Implemented EDSR using C++ with OpenCV for efficient high resolution processing. Applied Wave 2x via C++ converter for a style preserving upscaling and denoising. Evaluated models using PSNR and SSI metrics for quality assessment. Compare results based on image quality, processing speed, and application suitability. These are the key technologies used. The platform used and the tool used is C++. The library is OpenCV for image processing and optimization, models, dataset, 2K for super resolution training, and benchmark. Image formats, JPEG, and WebApp for compatibility and efficient storage. The platform used is Linux platform for development and execution. So these are the results of the performance analysis. So the discussion is bicubic interpolation is fast and efficient but causes blurring and detail loss. EDSR provides the best image quality with high detail preservation but with high computational power. Wave 2x balances quality and performance, especially for styled or anime images. There's a clear trade-off between speed and image quality. Method selection depends on application needs and hardware availability. The conclusion is bicubic interpolation is fast and simple but loss fine details. EDSR achieves superior quality and detail preservation. The next one is the effective for styled images, offering both upscaling and denoising. No single method is best for all. Similarly, choice depends on image type, quality needs, and processing capacity. Hybrid or adaptive approaches could improve versatility in future image upscaling applications. So thank you, ma'am.
Thank you. What is the nobility of your work? Hello. Okay, let's move to the next presentation. I hope she won't be able to hear.
Yes, ma'am. I'll move on to the next presenter.
Yeah.
Our next presenter is Sanson Sando S. Sir to present his paper titled A Multi-Objective Cuba Framework for Real-Time Sustainable Vehicle Routing. Sir, are you present? Okay, if he's not present, we can move on to our next presenter, Tarun Arora Sir, to present his paper titled Artificial Intelligence, Enabling Sales Personalization and Stakeholder Engagement in the EdTech Industry. Over to you, sir.
Thank you so much. Good morning, everyone. Good morning, Dr. Meenakshi. My name is Tarun, and I am working in EdTech industry, and I'm a professional, and therefore it enticed me to do my PhD. And now this paper is entirely focused on that one. So allow me to share my screen.
Yeah, please go ahead. All the best.
Thank you so much, ma'am. Is my screen visible, ma'am?
Yes.
Just So, as the title says, that we are working on enabling the sales personalization and stakeholder engagement in edtech industry by using AI. So, what it happens is, if we see edtech industry these days, especially, I'll talk about a background first. Uh, So in last few decades, what it has seen is the adoption of technology in the classrooms have been impacted, and not only in the classrooms but also overall. We are jeopardized with a lot of technology around us, and same is the case that it has been done to our educational institutions. The adoption of technology, whether it is a smart classrooms, whether it is cross I was just listening to one of the paper in the beginning that there was talking about gamification of the content. So that is also you are trying to bring a technology, trying to bring a edtech solution in one of the classroom so that the learning outcomes are better. So the background, we have a lot of papers around it, and COVID act as a catalyst around this industry to boom immediately because the hybrid model was engaged. The teachers who were using chalk and dusters in the classrooms are being shifted to Google Classrooms or Zoom platforms or the other platforms, and therefore the adoption of technology becomes much more easier because the mental barrier was removed because of the pandemic we had seen everyone. So therefore, this paper is addressing that what are the important challenges as an industry in edtech that we all are facing, because there are multiple stakeholders when it comes to technology adoption in the institutions. One is the end user, which we call as teachers and students. The second one is the management who decides what technology has to be opt in. And the third one is the IT infrastructure. Are we are able to do it? And fourth and obvious challenge is the financial depth, that what kind of an investment is required to adopt that technology in the classroom. I'll use one example here to traverse the entire presentation, including the background as well as how the model will be adopting. So I'll use an example of using, people get confused whether to use smart boards, which is interactive flat panels, or the projectors. I'll be using this example to quote everything because this understands by most of them, but this is just one of the smallest technology that is being used in the edtech these days in classroom. So we will be using how the AI powered tools and techniques help us to use new technology in the classroom. So my model is working on how the AI will be helping and making easier for the adoption of technology in the edtech industry. So that's the context and background. Now, what is edtech? Edtech simply means that technology in education. So how it is, it could be infrastructure, it could be learning management system, it could be learning outcomes evaluations, as we were talking about a model wherein it was clearly, just a second. Yeah. So in this, what we'll be understanding is the scope of edtech. Like more than the online instruction these days, what it happens is we see there is an online instructions happening. There is a blended instruction happening. Now in blended instruction, one of the major challenge happens is the teacher is teaching in a classroom and the students are sitting. Therefore, the interaction is happening. But what happened to a student who is sitting far across, who has joined online platform? So the cameras has to be PTZ cameras. So generally what we think in a meeting room, PTC cameras are not applicable, but those are the solutions are there. And then your mic is connected only to a teacher, but there could be sound enhancers that could be adopted in a classroom. Therefore, if some student sitting on the on the back side of the room is also asking a question, so the person sitting across the hybrid platform would be also able to hear, listen, and engage and properly. So therefore, that is one of the solution that I'm just giving you an example. Like, what is edtech? It's about online instruction. It's about digital tools, which are LMS, content delivery, and about the student learning behavior and engagement interactivity. So these tools helps them to do that. Now, in the literature review, there are a lot of papers that has been published in the past. One of the, and I'll be using a few names here to which I thankfully, because they have done a work very well in that one. So there is communication through teacher can help in building up the engagement with that tech platform. So if we do engagement as a solution provider, if we understand the teacher requirement first, because there could be a teacher who is a technology enabled, there could be a teacher who is into social sciences but not very well versed with technology. So we need to understand from their perspective. So in this paper, the author has very well explained that how we need to collaborate with all the teachers who are the end users and engagement. Then how the integration happens, what are the role of different stakeholders in edtech industry plays a crucial role. For example, I'm a finance manager for an institution and I don't have budget to implement the technology that everybody is looking for. Then what are the alternative methods can be implemented? What is the role of a management who is um, who is actually, for example, in change, I would say there is a behavioral change in this. So there is a paper which I was reading in the past wherein it was mentioned very well that the adoption of technology was major challenge was user adoption. The user are not ready to adopt a technology, or management is forcing them to use LMS or the teaching tools. At the same time, country like India, we have challenges like we are using IFP, and for one fine given day there is an issue in power supply, and there is no electricity in the classroom. Therefore, the class got jeopardized because now the traditional whiteboards are replaced by IFP panels. The teacher had to cannot do anything because you are restricted them. So what are the alternatives? So in that, during discussion, the IT manager proposed the other solution. So therefore, there are a lot of stakeholders who sits and discuss. And therefore, in this, the AI model is required because a lot of people don't understand the version of how the end user is gonna work, how the middle management gonna work, how the suppliers are going to supply, because there is a lot of competition from their angle. So that is very well explained in the role of diverse stakeholders in edtech industry. Somebody who's from the sales background for IFP panel doesn't understand what teachers are required to understood. Therefore, similar is for finance, for accounts. So I'll not take much of time here. I'll move to the next slide. So these are the challenges what we have actually understood. There are a lot of data, a lot of trust issues because there are data that get stored into LMS and the user information can get leaks. There could be a cyber uh, attack, and how the routers and firewalls gonna save your data, or your data is stored at your local cloud, or it is stored at someone's cloud. So how those basic challenges which you do not understand while using an LMS or I would say university management system, to just to make it simpler. So and there is a lot of uncertainty and unpredictability in the education scale because of the speed. This industry is growing at a very fast pace, and still we are not ready in terms of the predictability. There are lesser predictability softwares at the moment in terms of understanding where this industry is going. And then obviously the ethical implications is a human behavioral challenge. We need to impart education for the implementations, and cultural shift from a traditional classroom method or a traditional learning to a blended learning, to a hybrid learning, or to a examination evaluation, to a hands-on activity. And now it is being moved to uh, more about not about exams but to do practical outcomes. So that is also one of the key challenges that we see as an edtech industry experts. Now, what does the role of AI? Now, how the AI will do? So, in a B2B sales, AI is we will be making a model that can create the interactivity between different users. So, all of the users will have a different kind of layouts. Therefore, they'll be able to understand what is the accuracy forecasting. For example, I wanted to build a lab, or I wanted to build a smarter classroom. Then how the AI adoption will help me. Decision makers will be able to have a clear mindset because of this implementations. Yeah, AI will be able to help them to give, as a finance or as a management, they look at ROI. So ROI will be calculated by AI. From a teacher perspective, it will help them to understand how the classroom engagement will be better. From a IT infrastructure, they'll be able to see how the users are being taken care of and how the security layers are being implemented, and also the tracking of teaching in the classroom, whether the students were attentive, the content delivered in the classroom was as per the uh, scope and sequence of the subject and as per the lesson plans. So all these things can be tracked by AI by using these things and by using the technology adaptation here. And
Dear presenter, can you please speed up? You have 1 more minute left.
okay, ma'am, sure.
Yeah.
And then what model we gonna propose is, this model has four pillars. One is emotional engagement. Second is the cost-effective automation. Third is the education level based on the sensitivity, sensitivity, which means what content has to be taught. And then the fourth one is it is balancing the individualization and privacy. So we are focusing on the four pillar, and the four users will have a different kind of user engagement with the uh, technology consultants, and therefore it will help with the overall layer on of AI on top of it. This will help them to collaborate and bring the technology in the classroom. So now if I need to conclude, and this is just a model that I'm going to propose, there are a lot of research can be done on post of it, because the paradigm is shifting in how the edtech industry connects and learners and customize the experience through AI adoption. This study will be highlighting on the paradigm shift. The findings will demonstrate the AI-driven attributes, and also we will be doing a mediating factor. We'll be calculating the mediating factor here in terms of the research, and we will have the strong foundation for the understanding of improving human AI interaction um, within the educational environment. So it will be improving the AI interaction within the educational environment, emphasizing the technical capability alone is insufficient, but also the user adoption is important here. So we'll be using all these parameters to understand and to allow the adaptability of the technology. And the future scope is obviously there is a lot of future scope since the AI is accepted and user trust dynamics can be greatly discussed in two different geographical contexts, because what it happens in territory A will not work in territory B. So therefore, you can do there is a longitudinal study for behavior tracking can be done. Uh, you can do a real-time individualization based on reinforcement learning can be checked on based on the user feedback loop, and then we can also do a multi-criteria decision-making techniques such as to analytics, hierarchical, total, imperative, structural modeling, etc. Anything can be done in these things. And these are the basic references that I've used to write this paper. Thank you so much.
Thank you, Tarun. Personally, I wish you best of luck so that you succeed in this project.
Thank you so
Actually,
much, ma'am. Thank
and
you
this
so
is
much.
really required nowadays era of this chat GPT and all that. Students are not engaging in the classroom activities. So if the automation will be really in the implementation, so it will really help to the students to be get engaged.
Ma'am, one of the use case I cannot disclose the end user. Today I'm in Oman. I'm working with one of a university over here where we are implementing a hardware technology to
Okay.
create this is a pilot program, by the way. So in that the
Okay.
classroom we'll be able to analyze based on the scores what they're gonna get it, how
Okay.
much they were involved in the classroom. So it's a study for 6 months that we're gonna
Yes,
do
this
it in that.
involvement. Yeah, exactly. This is required.
So that will help us to understand why he was good in mathematics and why a
Mm-hmm.
student was not performing well in the other subject. So that will be
Mm-hmm.
indicative. So I'm working on that project as well based on AI.
Yeah, that's what I'm telling you. It's too interesting. It is required nowadays to
Yeah, yeah,
understand
thank you, ma'am.
the students' behavior, to make them to connect with the teachers and connect with the subject that they are learning. It is very much required.
Yeah.
Anyhow, how far you have implemented this one? And what means
This
I was
this is
asking you
in a
what phase you are. Uh,
this is in a proof of concept stage at the moment. So we have done
mm-hmm.
the hardware setup there. We are
Mm-hmm.
training the models. I cannot disclose because of the
Mm-hmm.
non-disclosure agreement with the end users and the
Mm-hmm.
technology that we are using there. But we have done
Okay.
a lot of hardware interactivity. Now this semester we gonna understand. We gonna actually the over here in the Middle East, what challenges we when you are capturing someone, you have to take their consent that you're gonna use their data. So even in that classroom, only very restricted students who have given us the consent will
Mm-hmm.
be given the classroom engagement.
Okay.
Yeah,
Okay, thank
so
you,
we'll have
Tarun.
the data after I think from now almost 6 to 12 months. We'll have some certain data based on it, and we'll be able to work on that. Yeah.
Mm-hmm. Okay. All the best.
Thank you, ma'am. Thank you.
Yeah.
Thank you, sir, for your presentation. Now, I would like to call upon our next presenter, Manish Kumar, sir, to present his paper titled Design and Implementation of an Automated Deployment Orchestrator Platform. Over to you, sir.
Am I audible, ma'am?
Yes, you're audible. You can share your screen.
Is the screen visible, ma'am?
Your screen is visible. You can start.
Okay. Good morning, sirs and ma'ams. I am Manish Kumar, pursuing final year of my BTech from Ajay Kumar Kark Engineering College with a specialization of information technology. So my topic is, as the name suggests, that we are working on a platform, an automated deployment orchestration platform, which is a cloud deployment platform. Mm, so the content is motivation, content, second one. Content is motivation and problem context, literature survey, research gaps, problem statement, proposed methodology, results and discussion, conclusion and future works and references. So talking about motivation and problem statement. So, so as we can say that we see that development is not all about writing the code. It's all about writing the code uh, uh, and serve the functionality to the end user who use that platform. So when we write the code mm, that works on our local machine, no, not everyone cannot use that code to second one. मैम हम देखते हैं कि केवल कोड को लिखना ही सब कुछ नहीं होता, उसे डिप्लॉय करना और एंड यूजर तक पहुंचाना एक सक्सेसफुल डेवलपर का काम होता है। लेकिन जब हम देखते हैं कि डिप्लॉयमेंट इतना इजी नहीं है। जब हम कोई भी प्रोजेक्ट बनाते हैं, उसे डिप्लॉय करते हैं, तो उसमें काफी सारे मैनुअल टास्क होते हैं, लाइक हैंडलिंग द एनवायरमेंट वेरिएबल्स, चूजिंग द राइट रीजन टू रीच द एप्लीकेशन globally accessed by the end user. But it is not a simple task. It is hard to deploy your application so that everyone can access it globally. So uh, so uh, we uh, uh, we uh, we we are working on an idea which is single click deployment system and automated deployment system, in which we are working on a platform in that user only uh, need to give the code to our platform, and whole work like setting their environment variables and is choosing right reason, and all other backend tasks will be automated, and in a single click your application will be deployed on the cloud, so that everyone can access it using a link. So literature survey, CI/CD, only CI/CD like Jenkins cannot handle it alone. Traditional deployment pipelines like we uh, we are manually we are manually creating Docker images and deploying it on Kubernetes. Uh, this is also a crucial task. So and container orchestration, that is Kubernetes, which is a orchestration platform uh, to handle the traffic on the website but manually it is hard to handle Kubernetes cluster. Intelligent orchestration and monitoring is also a crucial task, like how traffic is increasing, and how much memory is consuming, and containerization Docker, which provides a package, a complete environment to run our application in the cloud environment. Next topic, talking about research gaps, insufficient deployment and safety. Insufficient deployment means mm, not handling proper environment variables or data, limited support for dynamic microservices, which is when we are creating a monolithic application, and gradually it grows. So hence the traffic is going to increase on the platform. So many times the many times the application gets busy or get stuck. And the third main point is rollback mechanism. When we are building the application and after some time we release a new version of the website, but as the new version doesn't work properly, that there is a no mechanism to roll back the previous version. So in our platform, the main function of the platform is candy rollback deployment, in which we deploy a new version of our application, and we try to we send some 30% of the traffic to the new version and 70% of the traffic to the previous version. And as the new version will work correct correctly, then uh, gradually uh, we send the more traffic towards the new version. Problem statement. On Docker and Kubernetes are the uh, main tools uh, to play the role in the deployment, but they are hard to manage. They are hard to manage. Developers frequently face pipelines, limited visibility, manual rollbacks, using unsafe release, leading to production and downtime. Uh, when we release this new version, so we have to manually roll back our we have to manually roll back our previous version if the new version doesn't work expectedly. Proposed methodology: problem discover and safety conceptualization. Widely used deployment we explore many platforms like Render, Railway, and Heroku, Netlify, but there is no platform which in which we can see our live visualization of the deployment in a stage by stage, like patching environment variables, cloning repository, and deploying the application. There is no platform which clearly shows the stage by stage deployment of the platform, and there is no platform we found in which candy rollback mechanism is candy rollback mechanism was developed. So platform, in our platform, uh, we designed we designed we designed a functionality of deployment platform and live visualization timeline, in which when the user paste its when the जब यूजर हमारी repository के यूजर हमारे गिटहब की repository देगा, तो सबसे पहले repository builder काम करेगा अपना और repository को क्लोन करेगा. देन उसके बाद आता है हमारा विच प्रोजेक्ट का टैग स्टैक, कि वो किस टैग स्टैक पर बेस्ड है प्रोजेक्ट, ये ये फैच करेगा हमारा मॉडल, हमारा प्लेटफॉर्म. देन उसके बाद एनवायरनमेंट वेरिएबल सेट होंगे, और रीजन को देखा जाएगा कि किस रीजन में हम किस रीजन में अपने एप्लीकेशन को डिप्लॉय करना चाहते हैं. उसके बाद डिप्लॉयमेंट स्टार्ट होगी, और एक विजुअलाइजेशन टाइमलाइन जिसमें स्टेज बाय स्टेज प्रोसेसिंग दिखाई जाएगी कि अभी हमारा जो डिप्लॉयमेंट है वो इस स्टेज में है, देन उसके बाद इस स्टेज में है, और आफ्टर दैट फाइनल डिप्लॉयमेंट स्टेज आएगी. तो द रिजल्ट एंड discussion. In result and discussion, we can clearly see that manual deployment is very hard. In render, in render uh, we reduce the deployment timeline by 20 seconds, and in railway we also deploy. But
Dear
in our
presenter, you have 1 more minute left. Please speed up.
okay, ma'am. In our platform, we reduces the deployment timeline also by the 20 seconds. conclusion matrix, deployment timeline we reduce, rollback time. It is a rollback time also reduces, detection accuracy 0%, automated, no automated detection. This is a manual work. In our platform, we can clearly see deployment timeline, rollback time, manual, रेंडर एंड रेलवे में रोल बैक टाइमलाइन मैनुअल है, रोल बैक टाइम मैनुअल है, डिटेक्शन एक्यूरेसी नहीं है, ट्रांसपेरेंसी स्कोर जो है वो भी कम है, एंड रिकवरी सक्सेस रेट 63% एंड 67%. टॉकिंग अबाउट कंक्लूजन, आवर प्लेटफॉर्म जैसे सर कोई भी अगर हैकाथॉन्स वगैरह होती है तो उसमें हम देख सकते हैं कि जो भी स्टूडेंट्स होते हैं उनको काफ़ी प्रॉब्लम होती है अपने प्रोजेक्ट को डिप्लॉय करने के लिए. तो अगर तो हमारा प्लेटफॉर्म क्या करेगा, उस टाइम उनके इस मैनुअल टाइम को काफ़ी रिड्यूस कर देगा और उनके लिए इजी होगा काफ़ी कि वे अपने अपने एप्लीकेशन को इजीली डिप्लॉय कर सके और अपने जजेस को दिखा सके इजीली. और उसके जो भी छोटे स्मॉल ऑर्गेनाइजेशंस होते हैं वे भी अपने प्रोजेक्ट्स को इजीली डिप्लॉय कर सकते हैं कुबरनेटिस क्लस्टर पर. Talking about future scopes, we can also integrate AI models to automatically remove the bugs in code while deployment. एक्सटेंड और हमारा जो क्लाउड प्लेटफॉर्म हमारे प्लेटफॉर्म में हम एक्सटेंड कर सकते हैं मल्टी क्लाउड डिप्लॉयमेंट लाइक Azure, AWS, GCP. Security compliances and policy enforcement mechanism. Conduct user-centered studies for productivity and scale. Also, scalability is the major aspect to handle the increasing workloads. References, we also studied about these all the papers which have already been published related to deployment, and after that we started working on this project. Thank you, ma'am. That's all about our project.
Okay, thank you and all the best.
Thank you, ma'am.
Yeah.
Thank you for presenting. I would like to call upon the next presenter, Ayushi Raghuvanshi ma'am, to present her paper titled Emotion Detection and Classification from Social Media Text Using Ensemble Learning. Over to you, ma'am.
Yes. Is my screen visible?
Yes, it's visible. You can start.
Okay. So, good morning, everyone, and the judges. My name is Ayushi Raghuvanshi, and I will be presenting you the research paper titled Emotion Detection and Classification from Social Media Text Using Ensemble Learning. So, coming to the introduction part, what happened is in today's digital era, users constantly express emotions through text on platforms such as social media, live streams. However, emotion recognition from text is a challenging NLP task because text is often short, noisy, informal, and context dependent. So, emotion analysis help in understanding the user mood, engagement, reaction, also which is the useful application for mental health monitoring, social media analysis. Unlike traditional sentimental analysis, which focuses only on positive or negative, a system recognizes six basic emotions that are joy, anger, fear, sadness, love, and surprise. So, to improve accuracy and robustness, we adopt an ensemble learning approach which combines the strength of multiple machine learning models. Coming to the literature survey part, so we studied both machine learning and deep learning approaches for emotion detection. So first one is the Venkateshwar proposed a hybrid LSTM CNN model and achieved a good accuracy on Hindi and English social media data, but performance dropped while when contextual understanding was weak. While second was the Maldiv and Giri proposed a hybrid LSTM CNN model and achieved a good accuracy. Sorry, Maldev and Giri showed that CNN-based models performed well on the ISEAR dataset. However, emotions like fear and surprise were underclassified due to the missing content. So coming to this, Seth E. had highlighted that the ensemble approaches often outperform individual model, but most studied were limited to offline dataset. So there was another review study focused that on surveying deep learning techniques are lacked real-time implementation. So after studying all these kinds of research paper, what we have found is mostly existing works were focusing on the offline data, lacking of the real-time deployment, and struggle with the contextual emotions such as the sarcasm or ivory. So this motivated us to design and real-time stacking ensemble framework for emotion detection on the social media live streams. So coming to the methodology part. So now I will explain the methodology of a proposed system. So here we have used the emotion label dataset, that is the Hugging Face dataset, which have the 20,000 textual comments, each labeled with one of the 6 emotions: anger, surprise, joy, love, sadness, and fear. Each data instant consists of 2 columns. So one's the comment text and its corresponding emotion label. So for model training, emotions were numerically encoded from 0 to 5, and the data set was divided into 80% training, 10% validation, and 10% testing samples. So one of the major challenge we were getting was the data set was totally imbalanced. Like emotions like joy and sadness are overrepresented, while surprise had fewer samples. Additionally, the text data was unstructured, containing slangs, emojis, URL, abbreviations. So to address this, we have used text pre-processing using NLTK library. And to balance the data set, we have applied text augmentation techniques so that if some words are missing, we would insert it. If some words are extra, like we are going to delete it. So we have also used the random oversampling and class weight learning to prevent model bias towards the majority classes. After pre-processing, we are converting this text into the numerical features using TF-IDF factorization. So we assign the weights to these words based on the importance within documents and across the data set. So for classification, we implemented multi-null naive bias, support vector machine, random forest, and logistic regression. To further improve performance, we adopted an ensemble learning approach, especially the stacking in this approach, and produces the final prediction. So what happened is predictions from this base classifiers are combined and passed to a meta classifier, which produces the final prediction. So this strategy significantly improves robustness and accuracy compared to the individual models. Now coming to the application part, where we have used it into a real-time application, that is the YouTube live stream URL as an input. So what we are doing is as the user provided a YouTube live stream URL as an input, using YouTube data APIs, the system fetches the data in a real time. These comments are immediately passed through the same NLP pre-processing, TF-IDF extraction, and stacking ensemble classification, which I've explained earlier. So the output is displayed on a real-time dashboard, which visualizes sentiment distribution, emotion-wise frequency count, and the percentage distribution of emotion, as you're looking in this image. So this dashboard allows content creators, researchers, and marketers to instantly understand audience, mood, and engagement during a live stream. Now coming to the result part. So the proposed stacking ensembled model achieved a higher accuracy and FN score compared to individual classifiers. That's why we have used the ensembled approach. So random forest and logistic regression showed a strong baseline performance, but stacking further improved the overall result by combining the multiple predictions. So the system successfully classified all the 6 emotions from the YouTube live comments. So the real-time dashboard effectively by both like the sentiment and the emotion distribution. So coming to the conclusion and the future scope. So to conclude, the research demonstrate that a stacking ensemble-based NLP framework can accurately perform real-time fine-grained emotion detection from live social media data. The system provides actionable emotion-aware insights useful for social media monitoring and mental health analysis. Coming to the future work, what we have thought about doing it in a more future is like this framework can be extended to multimodal and multilingual emotional analysis by integrating speech to text, audio tone, and visual cues. That's all. Thank you.
Okay, thank you, Ayushi.
Okay.
Thank you for the
Will you tell
presentation.
me 4 models you have taken?
Yes, ma'am, your voice is not audible. Wait. Yes?
You have taken 4 models for classification.
Yes, ma'am.
Okay. From that, one is SBM, one is naive Bayes,
Yeah.
one is logistic regression, and one
Yes.
more is
Support vector machine, SVM.
support work. No, SBM I told. Say SBM, naive Bayes, logistic regression. One more is there.
Multinomial naive Bayes.
Naive Bayes with multilevel naive Bayes.
Yeah.
Okay. Only naive Bayes and multinomial naive Bayes. What is the difference?
Yes, ma'am. What?
What is the difference between only naive Bayes and multinomial naive Bayes?
Ma'am, naive Bayes is like it's just giving the probability as like 0, 1, 2, 3, 4. But combining the multinomial naive Bayes is designed for text data and works on word frequency count, like how many times the word is getting repeated. Like suppose the text contains love, right? So it's the emotion is telling is there is joy, right? So we will count that
Input
word.
Just tell me input is categorical or continuous.
Input is categorical or continuous? Input is
Hmm.
categorical.
Categorical. Logistic regression, input is categorical or continuous.
Input logistic regression. I think input is continuous there.
If your data set is 1 and you know that SBM generally we give continuous value, logistic regression we provide continuous value, then why you have thought of choosing naive Bayes which is taking categorical value? Why this combination you have taken?
Ma'am, naive Bayes is chosen because the computationally it is efficient and effective for high dimensional text data.
There are so many continuous value. Finally, you tell me ki from your data set, whatever input you are giving, it is categorical or continuous.
Ma'am, AT is categorical.
It is categorical. If it is categorical, then you should have taken naive Bayes, you should take decision tree, you should take some other the machine learning models which are basically designed for the categorical. In spite of that, you have chosen SBM, which is designed for continuous value, linear logistic regression designed for continuous value. So, how you have converted your categorical value to continuous value? Then only you can apply it to this now. So, what
Yes.
is the pre-processing step you have taken to convert it to categorical to continuous in order to apply to the SBM, logistic regression, and rest of the things?
So you are asking me of the pre-processing techniques I've used.
No, I'm asking if your input is categorical, it is
Okay.
okay to apply to naive Bayes directly. But how you have applied to SBM? Because SBM is designed for continuous value processing. Similarly,
Ma'am,
logistic regression is also.
ma'am, because these models, I think they are working better while using it because these are giving us the better output compared to other models which we were using earlier.
I hope you got my question. You get the answer from from the Google. Okay.
Okay, I will take it.
Thank you.
Okay.
Moving to next.
Thank you for your presentation. Now, I would like to call upon the next presenter, Malvika CV, to present her paper titled Folk Fusion, Deep Learning Based Classification of Indian Folk Dance. Over to you, ma'am.
Yeah. Am I audible?
Yes, you're audible. You can start.
Yeah. So is my screen visible?
Yes, it's visible. You can start.
Okay. Good morning, everyone. So I'm Malavika, and I'm here to present our research work titled Folk Fusion, Deep Learning-Based Classification of Indian Folk Dance. So to start with, Indian folk dances are an expression of the cultural heritage, and they reflect the rich diversity, customs, and the different communities across the country. So the costume worn by the dancers are not merely decorative elements, but they define the dance form and are a tool to distinguish one folk dance from another. So in the recent years, the challenge of identifying and classifying the dance forms solely based on costumes has become a significant research area. So the problem statement that we've identified is, identifying the Indian folk dances solely based on costumes. But this is actually a quite complicated task because when different dance forms are compared, there is a visual similarity that exists. So there is a need for a better sophisticated approach to facilitate costume-based feature extraction. Our objectives in this research work were first to develop a standardized image dataset solely focusing on Indian folk dance forms. So we also ensured that it captures a wide range of costume variations. It includes both male and female performers, and also we ensure that it captures the regional variations as well. And our second objective was to evaluate the performance of different deep learning models for costume-based feature extraction tasks. And then we wanted to employ TSNE visualization and XAI techniques to understand how these models were able to extract the features better and how the classification outcome is better. So, some of the research works that were presented earlier in this field were much related to deep learning frameworks. So we had a combination of CNN and LSTM models that were used with the image or video input for folk dance and classical dance classification. And two studies extensively focused on international folk dances. So one was related to the Turkish folk dances and the other was related to Greek folk dances using image and video inputs. And they used CNN-based architectures for classification. And the third most significant area was related to Indian classical dance forms. So basically, we had a paper that focused on 3D post reconstruction with Bharatanatyam dance form, and also Indian dance form classifications, like classical dance forms that included Bharatanatyam, Kathakali, Kuchipudi, and Mohiniyattam. Such classification was done with the transfer learning and deep learning models. So based on the existing research work, we found that most of them are focused on motion and pose-based features, and there was limited attention to the costume based classification, and also there was very limited attention to Indian folk dances. So we have tried to bridge this research gap. So for this, again, we had no standardized data set focusing on Indian folk dances. So we had, developed a data set for the Indian folk dances exclusively that has 6 classes, predominantly famous dance forms like Bave, Garba, Karagatam, Malvai Gita, Toda, and Yakshagana. So each of these classes had 100 images per class, and it came out to a total of 600 images. And we had an additional test data set for evaluating the models. So it had 10 images per class, coming out to a total of 60 images. All these images were gathered from various publicly available online sources like Google, Pinterest, and some were frames extracted from YouTube videos. So in order to improve the model's ability to generalize better, so we applied data augmentation techniques. So this helped in increasing the size of the data set by synthetically creating new samples. So moving on to our pre-processing method, this is the key step in this framework for costume-based classification because it helped in isolating the performer from the background. So here, after removing the background, you can find that the costume-based features are highlighted better. So this will be helpful for the model to learn the costume-based features better. So moving on to our methodology, in the training phase, we had our train dataset that was pre-processed with the background being removed, and then data augmentation technique was applied and it was fed to the model. So we had 4 models, deep learning models used for comparison purposes. One was a custom CNN, VG16, VG19, and EfficientNet. And moving on to the testing phase, we had the test data set undergoing the same pre-processing technique. And then we had the models for the prediction stage, and they'll give the final class as a predicted outcome. So moving on to the results, we can find that CNN has achieved a higher training accuracy, but the validation accuracy is quite low, suggesting it's a kind of overfitting. With VG16 and VG19, we had better performance. The validation and testing accuracies were balanced, but the performance could be much better. So with the case of efficient B0, we had better training, validation, testing accuracy. So it gave the most better and balanced performance. So from the experiments, we were able to infer that the background removal as the pre-processing technique was, the most effective pre-processing technique, and it helped the models in learning the costume features better. And also, while comparing the models, we found that efficient consistently performed well compared to the other architectures. So to explain the model's ability to perform well, so we had the TSNE visualization. So again, here the efficient model produced well-separated clusters. And with the line visualizations, actually here the blue regions contribute to the predicted class in a positive light. So this is just for a sample of images, but for most of the images, efficient B0 showed the costume features better highlighted. So to conclude, in this research work, we have developed a data set focusing on the Indian folk dances, 6 of them. And then we had, a background removal applied as a pre-processing technique to extract the costume-based features. And we had 4 different deep learning models evaluated, among which we found that efficient consistently performed well. So thank you all. I think I'm done.
Thank you, Malvika. Can you just move to your result slide?
Sorry, can you come again?
Result slide. Just show the result slide.
Oh, yeah. Yeah. Is it visible? Yeah.
Visible. What is the difference between this validation test and testing?
Okay. So this validation is actually part of the training phase. We'll have, the training data set split into 80% for the training and 20% for the validation. Testing is actually a separate pipeline over here. We are treating the validation to be a part of training. So this data set, has 2 different parts. So one is the train data set, and the other is a test data set. Test data set is evaluated separately. This validation samples are taken during training pipeline.
Split criteria, tell me. How much training, how much validation, how much testing?
Okay, so during the training phase, you have the training data set that will have 80% of split, and the validation will have a 20% of split. Among those, the original among the augmented samples, like you had 2,600 images, right? There, this 80-20% happens, and we had a separate data set with the 60 images that goes for testing.
Where did you get it? From the same data set it is there?
No. That we had because the some of the dance forms didn't have so much images available online. So we made sure that we have very new samples. I mean, the unseen samples kept separately for the testing. So that had 10 images per class, coming out to a total of 60.
No, that is you have captured from somewhere, or it is there in the data set?
No. We have captured it.
Acha, okay. What is the practical implication of your work?
So basically, like this can be used for the classification of the dance form when there is much background noise and all. So like we can identify and we can classify the dance form solely like referring to the costume features. So it can be used for cultural heritage applications and all, and learning purposes.
Okay. Okay, Malvia, thank you.
Yeah, thank you.
Thank you for presenting. Now I'd like to call upon the next presenter, Sandeep Bhanot, sir, to present his paper titled National Educational Policy 2020 and Sustainable Development, Impact on Educators and Learners in Higher Education Institutions. Over to you, sir.
Hello.
Yes, please go ahead quickly.
Ma'am, you can
Yes, sir, it's busy.
Hello.
Yes, sir, audible, sir.
Yeah. Yeah, ma'am. Okay. Hello. Hello.
Yes, sir, you're audible. You can start.
Yeah. Okay. Okay. Presentation slide show. Yeah. So the topic of education conference. Of awareness regarding life 2020 among teachers and students in the education institutions. So my other authors were Dr. Alchin, Kiran, Dr. Dhananjay Mankar, and Major General Dr. Bakshi. So these are my paper. Going to the next introduction. This new policy is a complex strategy for both rural and urban India that concentrates on vocational training from elementary school later higher education. So in 2020, it has like basically learning across various disciplines. Till now, we have seen that the policies mainly concentrate on learning at a particular discipline, whereas this policy had an instrument in encouraging teachers as well as students to participate in disciplines. And thereby adding to the creativity and the knowledge, skills, and even higher employability for students here. So the objective was to assess the extent to which students and faculty at and and the researchers also want to determine how satisfied the professors and students at these institutions might be in the new education policy, as well as what is the taking forward and forward thinking they have about its implementation, how they can. So these are the so there have been a number of studies done in the last 5 to 6 years since the policy came out in 2020. That was especially during good times, and the policy was initially and then were done with a number of authors. So one of the authors, Manik, he looked at how the implement goals. There's another study by looked at the possible impacts of this on higher education. Then there were other studies by L. Duraju, which claimed that existing Indian education system faced a lot of theoretical. So would this approach and lead to a situation where students would lay more emphasis on practical skills rather than knowledge. Then there was an article which examined the qualities in for higher education, benefits of various innovations and projects which this policy can offer. In various studies by Kalyan also investing stakeholders' perspectives, mainly the teachers and students. They are the stakeholders. So what are their and what are their views about then another study also talked about analysis, how the data like how the view attitudes different people towards policy. A lot of study was done about the methods, difficulties, because there are a lot of challenges also in the policy, and the criticism of any came from various areas. So how those particular challenges can that is also another very important so then there were studies about the key years and the guidance towards lots of any then how the end of we have among teachers and students, higher education students and the higher institutions this education policy and we would also want to utilize the satisfaction of the stakeholders, mainly the they feel also so various for this and characteristics such as age, degree of education, second was the perception of NEP, etc. And the significant based on again these demographics like its gender, of people's thought, and the of residents. So these were the hypothesis, the null hypothesis, alternate hypothesis, which were named, and then subsequently they were tested to find out what are the inferences coming of this. So for the features, similarly for students, we wanted to know whether there is any of NEP and then secondly, whether there is any similarly any significant disparity in perception with respect to the demographics like age and the education area of resist. And thirdly, to again the education, field of education, the area of residence. Hypothesis took was similar for the teacher and students. How does a perception vary and what are the how does score of the various demographic and also the level of awareness. These were the things we wanted to find out in this study. So the research design was basically like we collected data coming data Google Scholar for what is the level knowledge audience and attitudes. We conducted person interviews. So that we wanted had to collect. And once we quality data, we went to conduct based students. So this will be is their reliability using which came out to be in the first sub slides, then 0.7, which showed that the reliability of the questionnaire was high. And then we carried out that sophistic like keep the eye. So that's the basic we followed this entire paper. Informative was that
Sir, you have 1 more minute left for your presentation.
yeah, okay, ma'am. We found that the teachers were between 40 years of age. Majority of them were postgraduates. And the majority of them had an age of 10, 20 years. That were the teachers. And majority of them, 64, and their average score was 3.73, which indicated that teachers have responsibility to the and the average score of 3 point also indicates that teachers have responsibility to the statement that that board exam should be high. That's one thing which we found out here. And there was no segment in the age, gender, etc. And teaching management have shown a more favorable to NEP as compared to the others. For students, we found that the more of 0.8 was over NEP. And there was no significant in their awareness with respect to education, stream of education. Had the statement that function literacy and literacy limited. He has awareness and teachers, and which had education have been located. So was some information about how to use for implement of the education system. So majority of the teachers were found that there's institute taking due initiatives. And very and no significant relation found for demographics. And there was no significant relation between the awareness of NEP in the demographic variables. Majority of the students are aware about the policy, and more students also have given response to lastly was that in a become the it's not actually the largest in the world, and but still a long way to go. And the 2020 will in this direction of becoming one of the biggest economic superpowers in the next 15 to 20 years. And so we feel that emphasis must be given to policy and evaluation. The regulatory bodies and will get and get a policy of improving education. To find out from the teachers and students, and this extended to other regions also. Like right now, we have only by interviewing to other strategies. These were the references, and thank you.
Thank you, sir. You are doing a good work. I hope you'll be succeed in improving this one.
Sorry.
This is from my side, sir.
Any questions from anyone else?
No, thank you, sir. Next presentation.
Fine, ma'am. So thanks a lot for giving.
Thank you, sir, for presenting. Now I'd like to call upon the next presenter. Prajwal B. and sir to present his paper titled Weeding Crop Classification System Using Smart Farming. Over to you.
Visible, ma'am?
Yes, your screen is visible. You may start.
Okay, ma'am. Good morning, ma'am. Good afternoon. My project is weed and crop classification system using smart farming. In weeds are the major challenges in agriculture field where it compete for nutrients, soil, energy, light, and space. It ultimately reducing the productivity of the crop. As come to the traditional method like manual weeding and chemical herbicides are labor intensive and costly, and it will affect to environmental also. Um, my project mainly focus on developing automated weed and crop classification system using a deep learning technique like EfficientNet B3. Some objectives are we developed the extended crop and weed image dataset. Instead of taking a Kaggle direct dataset, we are adding a extra real-time images also. For improving the images, we add a clay preprocessing for enhancing the image construct and future clarity. The model we are used is EfficientNet B3, is a pre-trained model in the CNN to implement a smart recommendation system. If, for example, if we in the crop we develop the Parthium is developed, how to control the Parthium, it will give the recommendation for this. These are the existing system. We are existing the data set of soybean, broadleaf soil, and grass. These are the images which are in from the Kaggle image cleaning and resizing. They used the 4-layer customized CNN layers for split into 70% of training and 30% for testing. Some limitations in existing system is they used only one crop, which is soybean crop. They used only fixed data set, relies on open source dataset that may not generalize build real world conclusion. The problem statement is farmers often find it difficult and time consuming in identifying a weeds among the crops. Weeds grow along with the crops and compete for water, nutrients, sunlight, which reduces the crop yield. Traditionally, farmers remove weeds manually or by spraying the chemicals on an entire field, which is costly, labor intensive, and harmful to the environment also. The problem is develop a smart farming system that uses the images and deep learning to automatically detect and classify the crop and weeds. By correctly identifying the weeds, the system can help farmers to remove only the weeds among the crops, saving time, reduces cost, and protecting a crop and weed. This is the proposed system. User can take the input picture from the image, then send to the clay processing. It will enhance the image from the original to next level. After enhancing the original image, next go to the deep learning model EfficientNet B3 to classify the which crop and which weed. Then display the result which crop and weed, and display the summary of the result. After give the recommendation based on the crop or weed. This is the model workflow. Environment of setup and data acquisition. Prepare the system and collect the crop and weed images. Second one, load data set. It can be divided the split into training, validation, and testing images. After that, data pre-processing, data argumentation. Clean and enhance the images to improve the model training. Crop and weed and label each image which crop and which weed. Model development, we used the model EfficientNet B3. Model training, train and evaluate the model using a accuracy and confusion matrix. After that, save and export the model. Store the trained model for future use. These are the software requirements we are used. Programming languages like Python, deep learning frameworks, TensorFlow and Keras, image processing like OpenCV, and development environment like Google Colab, data set from Kaggle, and some real field images like Parthian has to be taken from real-time images. Some data handling visualization tools can or NumPy pandas are to be taken. These are the processors. Hardware requirements. Processor is Intel Core i5, RAM 4 GB, storage 256, graphics integrated GPU, and ML model training. Image acquisition devices, camera. This was the implementation. If we upload the image here, it will use this is the original image, this is the clay image. Then detection image is this is the detection image, which is crop and which is weed. That This is the overall detection of this project. Total detection is 10 detection. Crop type 6, weed type is 4. This is the overall implementation. Maize, the crop is maize. Detection weed is pigweed. Based on the confidence given, how much confidence it is maize only, that is given the recommendation. That gives the recommendation. Implement immediate post emergent. Based on the image, they give the recommendations. These are the references add user.
Thank you, Prajal.
Thank you.
Just one more thing. You
Yes,
know,
ma'am.
nowadays a lot of work has been done in this area.
Yes,
So you
ma'am.
just tell what is the novelty of your work?
Main focus on automated weed and crop classification.
Everyone is doing that one. Automation,
Yes, ma'am.
isn't it? Is it you the doing this work first in this area?
Yes, ma'am.
Is it you who is doing this work as a first person?
I can't hear. Ma'am.
I'm asking you, you know, lot of work has been done in this area. What is the nobility of your work?
Automated weed and crop classification. That's
But everyone is doing that. There are a lot of research work is already reported.
yes, ma'am. But we added recommendation system also and clay image processing, enhancement of the original image to enhance high quality image. That's also added, ma'am, in this.
You have captured this high quality image or database is already available.
Yes, ma'am.
I'm asking, have you ever taken the input from your side, collected the input, or you have taken the database available
Some beats
database?
are taken from my side only, ma'am. Real time images like Parthian, we are taken from real time images only, ma'am. I only taken it.
Acha, okay. So that means input you have collected.
Yes, ma'am. Yes, ma'am.
Okay. What kind of augmentation technique you have used?
What, ma'am?
What augmentation technique you have used? You told na data augmentation you have done.
Yes, ma'am.
What are augmentation technique you have used?
Data augmentation, ma'am.
Ah. Now, have you done data augmentation in your work or not?
No.
You have written
Data
data
processing, ma'am.
processing and data augmentation you have written, na? What data augmentation technique you have taken?
Jeez. Data
Okay.
process.
Okay, no issue. Rajal, go ahead.
Okay, ma'am.
You just doing great work,
Okay,
but
ma'am.
proceed with a good work so that it will be actually automation process and it will help the farmers as well.
Okay, ma'am. Okay, ma'am. Thank you.
Mm.
Thank you, ma'am.
Okay.
Thank you for your presentation. Now I'd like to call upon the last presenter, Sanson Sando S. Sir, to present his paper titled A Multi-Objective Cubo Framework for Real-Time Sustainable Vehicle Routing. Sir, are you present? Okay, I think he's not present. Okay, so we can finally move towards the closing remarks. I would like to sincerely thank all the authors for the excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. And we'll be happy to have you next year in the 11th version as well. All the presenters would be getting their digital certificates through email within 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of SMARTCOM. And lastly, I would like to thank our session chair, Dr. Meenakshi Raut, for chairing the session. Here is a token of appreciation to the chair on behalf of Team SmartCom 2026 and Global Knowledge Research Foundation and partners. Thank you, ma'am, for your valuable presence. Before finally ending the session, I kindly request everyone to switch on their cameras for a quick snapshot of the virtual conference. Can everyone please on their cameras?
Thank you, Gayatri. It was really a great
Thank you, ma'am.
session. Yeah. Thanks to all the participants and also all the best so that your research works you should carry on. You are really doing a great work. And as Gayatri told, they are looking forward to for the more publications in the next version of this SmartCom 2026. Thanks once
Yes,
again.
ma'am. Definitely.
Yeah.
Yes, thank you, ma'am. Can you all please on your cameras for a quick snapshot? Yes, thank you. The snapshot is done. Now you may all leave the meeting. I would like to end this session and stay safe. Take care. Thank you.
Gayatri, please send this photo. Can just send this a screenshot with me, huh? The photo, the
Yes, ma'am.
snapshot you
Sure.
have taken. Yeah.
Yes, ma'am.
Thank you,
Sure.
Gayatri.
Definitely. Yes. Thank you,
Yeah.
ma'am.
Okay.